Hey everyone, I'm now going to show you something that's very cool. You know, we have the AgonLight, and if we're programming, then you have a couple of options. You can program on the device itself with EZ80 or Z80 programming languages and IDEs, but you can of course also program on your modern PC and then make sure that you, after creating the program, you just actually upload it back to the AgonLight via the SD card, or maybe you have found a way to upload it via serial. So that's one way you can go about things. But then you still have another problem. If there's a bug in there, how do you debug? Now, then we have, of course, good old printf. We can, of course, try to print all kinds of messages to the terminal and find out what's happening. But sometimes the problems are so elaborate it's a little bit difficult. And then we actually would like to have a debug. We can, of course, use the Zilog IDE on Windows with, of course, the expensive Zilog cable. But as you all know, I created something else. Is with just two wires. You can actually connect to the ZTE interface yourself and communicate directly. Now, over time, I've built there a nice debug interface that you can use through the terminal. But of course, you can also do something even more amazing. I've integrated it here with Visual Studio Code. So you have a modern terminal and you have also a very nice interface with the debugger remotely. Let's have a look how that all looks like. What we're seeing here is a test program. I'm actually running the test program on Electron OS, which is a little bit different OS because it can assume personalities. And one of the personalities is the MSX personality. And on the MSX, you have a concept of cartridges. Cartridges usually start at 4,000 hex. And what this thing does, it loads a hello string, prints it, then goes into a video mode, and then starts to display a couple of interesting things. So this is all Z80 code. So let's see if we can compile and run the program while we're on, while we're actually going things. Let me see. So what you see here, program is being compiled, and it's actually now automatically being sent over to the AgonLight. It does this based on the instructions that are in the launch.json. Just standard, if you have a Visual Studio Code project, you have a launch configuration that says how to connect with the debugger, etc. And this thing uses the dzog debugger, a special flavor of it that I've built together with the author of dzog. What you see here, it loads a couple of object files in memory. A BIOS, which is a MSX BIOS in the MSX personality, and the test ROM that is based on this test ASM file. Very simple. And then it starts automatically and it runs. So actually, as you can see, I started it already and it's actually currently in debug mode. So what we can now do is give either go to the AgonLight, use the keyboard, type commands, which is still possible. Let us see if that's possible. I go over there to the AgonLight and I push the dir command and it all works. So it's actually, it looks like the AgonLight doesn't see that the debugger is connected, but of course it is. So here in the debug console in Visual Studio Code, you can actually put in commands, and one of the commands I put in is a command called vsync on. That is something for the MSX first personality to start driving the 60 Hz vsync. I'll just do it, nothing really happens at this point in time. So it's actually, the command is being sent over, and as you can see, it is also typed on the monitor. So it's almost a shorthand for typing stuff. And then I can, of course, say execute run. Once I do this, it starts the MSX personality, and here you see immediately breakpoint hit. So it immediately runs into the breakpoint at 1410 hex, which is after the kind of the ROM header, first thing that it does here. So a couple of interesting things. You can float over variables. It shows you where in memory it sits, 412B, for example. And as you can see, HL will assume that value. So it's now 4003. So let's just see if I step what happens. There we are. HL has been updated, and it all works. Now, of course, can do stepping, but then it would mean that I have to go all the way into the print function, etc. So I don't want to do that. So I'm actually going to step over here, and that's another function I've implemented. So as you can see on the other interface, on the AgonLight itself, a string called testing is now being shown. So that's pretty cool. This is all work on the terminal, and by doing this you can make a nice little program, step through it, etc. I've made it a little bit interesting. I've created an implementation of the MSX video chip on the AgonLight, and it's a TMS 9918, which is a very famous video chip, also found in various other computers of the 80s. I've now implemented screen 2 of mode 2 or something, and that is the graphics mode. So I'm now going to switch over to that mode, and as you can see, also on the AgonLight, the mode has changed, and you see it's running on a couple of little bit of different kilohertz. Now, if I then just press continue, it will just rapidly run the code, and it will show what the program will do. As you can see, I've chosen to make a pattern. It uses 3 segments. That is also how the video memory is built up. So I wanted to show, like, does everything arrive at the right thing? And I have one big sprite on top of it. This is a 16 by 16 sprite. And as you can see here, at every tick, which is every 60 Hertz, it takes the current position, makes it 1 higher, and writes it back to the VRAM. So I'm actually writing directly into the emulated TMS 9918 to update things. So that's pretty cool. What I can do is, of course, I can add a breakpoint here, for example. And if I do it, of course, it takes a little while. Boom, program stops, breakpoint is hit, and I can actually see things. So this is actually in the interrupt routine. You can see what's happening. I can step through it, etc., etc. So that's just very simple what it does. I'll remove the breakpoint and let it run. And there we go. So this is what you can do in the current version of the debugger. It's not 100% stable yet, working out on the latest bugs. And once it's ready, I will actually make a version of MOS, which has this debugger put in. Again, you only need to connect a couple of wires to make this work. If you see on the video, by the way, you see multiple wires there. Well, these wires I put in to be able to do some logic analyzing to see how the signals look like, etc. But that is not what you need to do in reality. So that's what I wanted to say today, and have a great day.